Bismillahirrahmanirrahim. We'll start this limits at infinity, where mainly what we are talking about. We're talking about limit x goes to infinity of a function, or limit x goes to minus infinity as a function. That's it. This is what they meant by limits at infinity. What's the meaning of that? So we'll determine the finite limits at infinity, and we determine what's called the horizontal asymptotes, or at infinity, maybe the limit goes to infinity. So the limits at infinity either go to finite, or it goes to infinite, or does not exist. Okay. So what is the meaning of this? I want to check the behavior of the function as x goes to infinity. As x increases without bound, x is going to infinity. The behavior of the function, is the value of the function becomes close to L, to this value L. So the value, so we say that the limit of the function as it goes to infinity is equal to L. The same thing, either it will come from up or come from down, or it will go up and down. So the horizontal asymptote can be crossed, but at the end, the function will go around y equal L. So it will either go above it or below it. It's okay, but it's go around that, or it becomes closer to L. And the same thing, if I say x goes to minus infinity, then I'm setting the behavior as x goes to minus infinity, which is doing the same thing. So the function is going closer and closer to L, closer and closer to L. Okay, so that's my data thing in this section. Now we'll try to do, first we define what's called horizontal asymptotes. What do I mean by horizontal asymptote? If what I said, if the function, if x goes to minus infinity and the function getting closer and closer to L, so we say y equal L is a horizontal asymptote. So in these graphs, y equal L is a horizontal asymptote in all of these 5 graphs. Huh? This one, that one, this one. So either x goes to minus infinity or x goes to infinity, I'm getting a horizontal asymptote. That means what? A function can have at most 2 horizontal asymptotes. Why? Because either I have x goes to minus infinity or x goes to infinity. I don't have any other things. So the function can have at most 2 horizontal asymptotes. Look at this function. From the graph, now we need to find the infinite limits and the limits at infinity. This means the function goes to infinity. This x goes to infinity. I need to check the behavior of the function. Here I have x goes to what? So the function goes to infinity. And here we have the vertical asymptote, and here we have the horizontal asymptote. Okay, so from the graph, it's very clear where I have a vertical asymptote. Vertical asymptote I have at 2. I have vertical asymptotes, and also at 0. I have a vertical asymptote. Where at 0, the limit, this is 0, this is minus 1, sorry. This point, which is minus 1. Okay. So at minus 1, as it goes to minus 1, the function goes to infinity from either side, from this side or from this side. So we say x equal minus 1 is the vertical asymptote. Here, the function from one side would go to infinity, from the other side it goes to minus infinity. I don't care. This is also will give me a vertical asymptote. So we have how many vertical asymptotes? 2. X equal minus 1 and x equal 2. Now, what about the horizontal asymptote? I say the behavior as this goes to infinity. As this goes to infinity, what will happen to the function? 1, 2, 3, 4. It will reach 4. So I have the limit as this goes to infinity of f of x equal to 4. As x goes to minus infinity, it will be equal to 2. The limit as this goes to minus infinity of this function, it will be 2. So I have how many horizontal asymptotes? 2 in this case. So I have y equal 4 is horizontal, y equal 2 horizontal asymptotes. For the vertical, x equal, since it's a vertical line. Now we need to study different functions. For the constant, what will happen? If you have the constant function, this is the constant function where I have k. So what is the limit as it goes to infinity of k? It will be k. As it goes to infinity, now it go around this, around k. Actually, it will be k, exactly. X goes to minus infinity. Okay, also it's k. So y equal k, a is a horizontal asymptote for the constant function. What about y equal x? The function y equal x, the line. This is the line y equal x. Yeah, as this goes to infinity, the function is going where? To infinity. So I have limit of x as it goes to infinity, that will be infinity. So I don't have horizontal asymptote in this case. What about the limit as it goes to minus infinity for the same function x? I'm getting minus infinity. We go to this, the function is going to minus infinity. What about y equal 1 over x? You notice I'm doing different functions. Y equal 1 over x, or what will happen? Limit x goes to infinity. From the graph, I'm going to infinity. The function is going to where? To 0. And the same thing from the other side. Minus infinity for 1 over x, it will be what? 0. So I have y equals 0 is the horizontal asymptote for the function 1 over x. Actually, more than that, if r is a positive rational number, so it will be in the denominator, a constant over x to the power r, it will go to 0. And the same thing, either x goes to infinity or x goes to minus infinity, I'm getting always 0. So, for example, the limit of x goes to infinity of c over x cubed, or x to the power 4, or x to the power 5, or x to the power 2.1, any positive value. The result is what? 0. And the same thing for the exponential function. You need to be careful with the exponential function. If you think about it, this is the exponential function, e to the power x. So as x goes to infinity, e to the power x, e to the power infinity, it goes to what? Infinity. What about as x goes to minus infinity for the same function? Oh, it goes to 0. So I have horizontal asymptote y equal 0. I'm trying to do different functions, huh? Yeah. Here, let me do y equal e minus x, not y equal x, e minus x. We'll do something like this. Now what will happen? Limit as it goes to infinity of e minus x, that will be 0. Yeah. Yeah. Just to be sure. Okay. So what is the limit as this goes to minus infinity of e minus x? That will be infinity. So we can think of the exponential function. If the argument of the exponential function goes to infinity, then I'm getting infinity. If the argument goes to minus infinity, then I'm getting 0. Then I'm getting 0. Now, if I want to do this limit, so what will be that? 5 is just 5. This one, 2 over infinity, which is 0. So 5 minus 0, which is 5. Here I have e to the power infinity, which is infinity. So I have what? A number over infinity, which is 0. Now, for the polynomials, for x to the power n in general, x to the power n, what will happen to the limit? If n is positive, the function goes to infinity, like x squared, x cubed. If n is negative, like 1 over x squared, 1 over x cubed, then the limit goes to what? To 0. Then the limit goes to 0. E to the power x we discuss. Sometimes he will give you, not e to the power x, but something similar. I mean, the same idea. Now, I have x goes to 0 from left. That means 1 over x goes to minus infinity. So e to the power 1 over x, as I said, the argument of e is minus infinity. Then the answer is this goes to 0. Tan inverse, this is the graph for tan inverse. So very clear, as it goes to infinity, the function is going to where? Around pi over 2. So for x equal to infinity, tan inverse goes to pi over 2. Minus infinity, I'm going to where? Around minus pi over 2. So tan inverse has how many horizontal asymptotes? 2. Y equal pi over 2 and y equal minus pi over 2. Okay, let me put one more page because I have 3 more problems. Let me try to do them in a clean page. Okay. What about y equals sine x or cosine x? What will happen? This is sine going in both sides. Okay. Now, if you want to check the limit, this goes to infinity for sine x. I don't know where it will stop. Today, we cannot have a specific value. I know it's a value between -1 and 1, but I don't know exactly what will be that value. So the limit does not exist. And the same thing, x goes to minus infinity, either for sine or cosine. The same idea. The limit does not exist. Now let me do these problems. Calculation problems, okay? Just need to be careful. Do it step by step. Limit x goes to pi over 2 from the right, e to the power tan x. Is it? Yeah. Now I need, if x goes to pi over 2 from the right, what is the effect of tan? This is tan. This is tan x. This is pi over 2. And this is the next x. Okay. So if x goes to pi over 2 from right, the function goes to where? Minus infinity. So tan x goes to minus infinity. So the argument of e goes to what? Minus infinity. E with minus infinity is what? 0. E as a limit, e to the power minus infinity, it will go to 0. Tan this limit is goes to 2 from right of tan inverse. I need to check first as this goes to 2 from right. 1 over x minus 2, it will go to where? This is the graph for x minus 2. Vertical, and this is, will do something like this, and this will do something like this. Okay. Now, as this goes to 2 from right, the function goes to where? To plus infinity. Yeah, it's very clear, non-zero over 0. So it's either plus or minus. Now it will be plus infinity. So this goes to plus infinity. So tan inverse of plus infinity, if you remember the value, I mean the function of tan inverse, as this goes, as the argument of tan inverse goes to plus infinity, tan inverse goes to what? To pi over 2. So this is the answer, pi over 2. Okay. Other functions. Polynomial, what's good about the polynomials? The control will be with the highest power. If I take x to the power n common factor, then all of these will go to 0. So the main idea in this limit is the same as this limit. So the control will be where? With the highest power, with the same, with the coefficient. Take it with its coefficient. And the answer will be plus or minus infinity. The same thing if I have a rational function, which is polynomial for polynomial, the control will be the highest power here by the highest power here. So this limit is the same as this limit. And that will lead us to this. If the limit of the numerator is less than the limit of the denominator, means this will be x to the power n minus m. If n is less than m, so this will be a negative, and they know that. The negative means that thing will be in the denominator, so it will be a number of infinity, which is 0. So that gives me 0. If they are the same, then this one will be x to the power 0, which is 1. So I have just a coefficient. If the numerator greater than the denominator, then either it will go plus or minus infinity. We need to check the sign. We'll do these examples. Okay. Now look at this one. Now the degree of the numerator. So I have this rule actually. If the degree of the numerator is less than the degree of the denominator, what will happen to the limit? 0. Equal leading coefficient. The ratio of the leading coefficient. Greater, then it will go either to infinity or minus infinity. Yeah. So here I have what? The degree here is 1. The degree here is 2. So the degree of numerator is less than the degree of denominator. So the answer is what? 0. Here I have the same degree. This is 2. This is 2. Same degree. The result, just the leading coefficient, 2 over 3. Here you need to be careful. The degree is more. So you need to deal with the control. This is the control. This is the control. to x, the highest power. Now do the calculation. That will be limit x goes to infinity, 2 over 3x. Okay, since x goes to infinity, infinity times the number will be infinity. Same thing here. Where is the control? The control is here and there. So this is will be, oh, no need to find do the control because it's the same degree. So the answer is what? 3 over 5. You can do this quickly. This is goes to 0. This goes to 0. So this is 2. This is the same power. This is 1. This one you need to rationalize it. Make this over 1 and rationalize it. See what will happen. That you will get what? X squared plus 1 minus x squared over this. Okay, so this is cancelled. So you have, this is infinity plus 1 is infinity. This is infinity. So you have 1 over infinity. I have 1, and the denominator goes to infinity. So 1 over infinity, which is 0. Let me do this later. Let me do this one. This is 4. This is 4, same degree. So just the leading coefficient, the highest power. This is 3. This is 4. So the degree of the numerator is less than the degree of the denominator. That will be 0. This one, it means is the control limit. It goes to infinity, 2x cubed over, no, 3x, sorry, 3x to the power 4 over 2x squared. So that will be limit x goes to infinity, 3 over 2x squared, and the answer is infinity. Yeah, let me do number 4 here. Limit x goes to, let me do infinity, and then I will do minus infinity. X minus 2 for absolute value of x plus 1. Okay. Now, as x goes to infinity, as I said, as we said before, with finding the limit, if there is an absolute value, first step, get rid of the absolute value. So if x goes to infinity, means x is positive, so this will be x. So I have this function, x minus 2 over x plus 1, same degree, leading coefficient, 1 over 1, that is 1. Okay, now, what will be the limit? As this goes to minus infinity for the same function. Be careful here now. Now, as x goes to minus infinity, means x is negative. So this one will be minus x. So this limit will be x minus 2 over minus x plus 1. So you have same coefficient. The answer is what? Minus 1. By the way, the asymptotes, here I have y equal 1, y equal minus 1. Here I have y equal 2. Here I have y equal 1. Here I have y equal 0. Here I have y equal 3 over 2. Here I have y equal 0. Here I have no horizontal asymptotes. Because the limit does not go to a value. Other functions like this one, exponential function, as I said, for the exponential, you need to be careful. If the argument of the exponential goes to infinity, then the function goes to infinity. If the argument of the exponential goes to minus infinity, then the function will go to 0. Okay, so let me do limit x goes to infinity of 1 over 1 plus e minus x. So the argument of e will be minus infinity. So all of this will go to 0. So I have 1 over 1 plus 0, which is 1. Now, what is the limit? This goes to minus infinity for the same function. Be careful here. This one will be plus infinity because times minus, minus times minus, infinity plus infinity. So this thing goes to infinity. So I have 1 over 1 plus infinity. If we can write it this way, so it's 1 over infinity, which is what? 0. So what are the horizontal asymptotes? Y equal 1 and y equal 0. Sin x, we discussed it before, where we said the limit does not exist. What about sin x over x? This is, I can do it by the squeeze theorem. Notice this is not 1. because the one if x goes to 0, now x goes to minus infinity. So this we can do it by the squeeze theorem. Divide by x. X is positive since x goes to minus infinity. So as x goes to infinity, this one goes to 0. This one goes to 0. So this one goes to 0 by the sandwich theorem. So this limit equal to 0. So you can use now limit sine x over x as it goes to infinity. We can use it as equal to 0. Different functions. X cubed. So I have infinity times infinity times infinity. So the answer is what? Infinity. So x goes to infinity and the function goes to infinity. This is what they call infinite limits at infinity. If you remember, we said we determine infinite limits at infinity. So x goes to infinity and the function goes to infinity. Okay. This one, I have minus infinity times minus infinity times minus infinity. So the result is what? Minus infinity. Here you can think of it, where is the control? The control with the highest power. So this limit is the same as this limit. So the answer is infinity. Or you can think of it another way. Take x common factor. Because I cannot do infinity minus infinity. Infinity minus infinity, this is infinity minus infinity, this is undetermined form. I cannot conclude. But if I take x common factor, I have x minus 1. Now this is goes to infinity. This is goes to infinity. Infinity times infinity will be what? Infinity with the same answer. Or you can do it by the control. Here, where is the control? Here and there. That will be 2x squared over x, so it will be 2 over x, or 2x actually. So the result is what? Infinity. But if x goes to minus infinity, the same thing. Of 2x, no, now 2 times minus infinity. This is minus infinity. Let me write it clearly. So the answer is minus infinity. Now, where is the control? The control is here, but in this one, the control is here. The highest power. The control is the highest power. X squared over minus x. That will be limit as minus x, which is minus infinity, which is minus infinity. Now, if I find the horizontal and vertical asymptotes, vertical asymptote we did, which is just yeah, we can do it easily. Let me do it. Vertical asymptote, x equal to y, because if we think of this as g over h, then h at 2 is 0, but g at 2 is not 0. So it's a vertical asymptote. We said for rational function, if the value in the denominator is equal to 0, but the value in the numerator not equal to 0, for sure we have vertical asymptote, not 0 over 0. Now, horizontal asymptote, let's check the limit. Yeah, for rational function, that will not make a difference. Plus or minus, just the highest power, the coefficient of the highest power, the leading coefficient of the numerator and denominator, the highest power. So I have the control here and there. So the value is 2. So I have horizontal asymptote y equal 2. This one you need to be careful. That will be x minus 1 times x plus 1 over x minus 1 or minus 2 times x plus 1. Okay, so for vertical asymptote, the possible ones are x equal 2 and x equal minus 1. For x equal 2, if I make this g of x over h of x, so I have h of 2 is 0, but g of 2 is not 0. So x equal to a is a vertical asymptote. Now in this one, I have a different thing. If minus 1 is 0 and g of minus 1 is 0, I cannot conclude. So I need to do what? The limit. See, the limit goes to a value or goes to plus or minus infinity. Or I mean the infinity category. Actually, what will happen? This will be cancelled. So I have a value. It will be minus 2 over minus 3, and that is 2 over 3. So x equal minus 1 is not horizontal asymptote. Okay, so that means the only horizontal asymptote x equal, only vertical asymptote is not a vertical asymptote, sorry, is not a vertical asymptote. So the only vertical asymptote x equal to. Now for the horizontal asymptote, it's the same degree. So just I will take the coefficient, the leading coefficient in the denominator and numerator. That will be 1. So the horizontal asymptote, y equal 1, is a horizontal asymptote. Now let us do some old exam problems dealing with different functions. I will try to do them quickly. Okay, here what I have, if we substitute, think about this, limit x goes to minus infinity, 2 over x plus 1. So you have a number over minus infinity. This is minus infinity plus 1, which is minus infinity. A number over infinity or minus infinity, that will not make a difference. That will be 0. Now, what will happen to the other one? Limit x goes to minus infinity of x plus 1 over 2. So what I am getting, this is goes to minus infinity. This is just a number. Minus infinity over a number, that gives me minus infinity. So this limit will be what? This goes to 0, and this goes to minus infinity. So it will be 0 minus minus infinity, which is infinity. That will be my answer. Okay, the graph of this function has how many vertical asymptote and how many horizontal asymptote. Okay, because usually the question is, we'll combine 2.5, 4.5 about the asymptotes. Huh? So let me first simplify it or factor the values. They have what? X minus or plus 4, x minus 2 over, I have here x squared minus 4, which is x plus 4, x minus 2, x minus 2, x plus 2. Okay. So now, what are the possible vertical asymptotes? They are at x equal 0, x equal 2, x equal minus 2. Yeah. So as I said, we'll make this g of x over h of x. I need to check the numerator. This is g at 0 will be non-zero. I don't care what is the value. So x equals 0, A is a vertical asymptote. G at 2, 0. G at 2, G at the 2, so we don't know. I'll check it with the limit. G at minus 2 will be what? It will be non-zero. Huh? So you have minus 2 plus 4 times minus 2 minus 4. It's not 0. Who cares what is the value? So for sure, x equal minus 2 is a vertical asymptote. Now let me check at 2. Limit is goes to 2 for this function, which means limit is goes to 2. Is it a value or it's just, or goes to plus or minus infinity? Over. This is cancelled. Now I can substitute. I'm getting a value. Will be 6 over 2 times 4. Who cares what is the value? But that means x equal 2 is not a vertical asymptote. Now, for horizontal asymptote, easy, because this is, I have a rational function, and the degree of the numerator is less than the degree of the denominator, that will be 0 plus or minus, the same thing. So we have y equals 0 is a horizontal asymptote. So we have one horizontal asymptote, one vertical asymptote, another vertical asymptote. So I have two vertical asymptotes and one horizontal asymptote. That's it. This one, same degree. So it will be the limit. Plus or minus infinity. This is the highest power. It will be leading coefficient minus 1. So y equal minus 1 is a horizontal asymptote. Yeah. For rational function, no need to do x equal infinity and x minus infinity alone. Huh? You can do it quickly. This one, same degree. So this will be the limit. So the limit will be 5 over 10, the highest power. which is half. So that will be the limit. Quick one. Which one, for example, is true about this? For the vertical, I need to do simplification. That x for x plus 5 over x to x plus 1. So the possible for the vertical asymptote, possible x equals 0 and x equal minus half. For x equal minus half, this is called g over h. So g of minus half will be not equal to 0. So x equal minus half a is the vertical asymptote. But for x equals 0, g at 0 is 0. So I need to find the limit, which is very clear. I cancel the x, so I'm getting a value. Cancel this, so I'm getting what? 5 over 1. So x equals 0 is not a vertical asymptote. What about the horizontal asymptote? We'll do the limit, since it's a rational function, either plus or minus at the same time. That gives me what? Leading coefficient for same degree. So it's 4 over 2, and that will be equal to 2. So horizontal asymptote y equal to is horizontal asymptote. So what is the answer? This is my answer. Y equal to horizontal, and x equal minus half is a vertical. Now this one, this is just a number, who cares? This is, we have what? Leading coefficient. So what is the leading coefficient? I have this and this. So this is will be 2 minus, this is minus this in the equation. Now this one you have what? 1 over minus 3. Or you can do it if you want to do it in details. We say this is the limit. And this goes to minus infinity of 2. Minus the limit is goes to minus infinity of this expression. So what is this? 2. And this one is 1 over minus 3, leading coefficients. I have this and this, which is what? 2 plus 1 over 3, 6 over 3 plus 1 over 3, that will be 7 over 3. That will be the answer. Sometimes you combine it with other functions. Now, this is actually 2.4. If tan inverse is continuous, I can take the limit inside. So this one will be tan inverse of this new limit, the limit of the things inside. And what is the limit of this? This is rational function. Degree of the numerator is less than degree of the denominator, so the limit is 0. So that will be tan inverse of 0, which is 0. So the answer is 0. Same thing. I have limit x goes to infinity. No, I can take the limit inside. So this is tan inverse of this limit. But what is this limit? Let me do it here. Now the control is here, and the control is here. It's not the same degree, and they're not less than the degree of the numerator is more than the degree of the denominator. So I'll do it with the control. So that will be limit x goes to infinity of x to the power 0.1. Since it's infinity to 0.1, that will be infinity. It will not go in the denominator. It will be just a positive value. 0.1 is a positive value. So that will go to infinity. So this one goes to infinity. This limit go to infinity. I need tan inverse of infinity. If you remember the tan inverse, as x goes to infinity, the function goes to what? Pi over 2. So the answer is pi over 2. That will be the answer. Yeah. Okay. See how far am I? Okay. Yeah, I think I'm going to go. Yeah, I'll do more problems, then I will stop. I don't like to have long video. Okay. Yeah. Now, a piecewise function. This is a piecewise function. You want to check horizontal asymptotes. Okay. The same idea. I need to find limit x goes to infinity. I need to find limit x goes to minus infinity with this function. Okay. X goes to infinity. So which category give me x equal infinity? It goes to infinity. This one or this one or this one. For sure it will be this one. Why? Because x greater than 4 means x is more than 4. So x goes to infinity will be there. So I'll consider this function then. 2 plus root x over 2 minus root x. You can do it same degree because, yeah, the square root, we can deal with it like the polynomial. Or you can do this trick to see it better. Divide by square root of x in the numerator and the denominator to see what will happen. The same idea as the same degree. Or the control. The control will be with the highest power, which is square root of x in this case. That will be what? That will be 0. This is 1. This will be 0. This is minus 1. So the answer is minus 1. So y equal minus 1 is a horizontal asymptote. Now when I deal with x goes to minus infinity, I need what? I need this. Since minus infinity is there. So that will be limit x goes to minus infinity of this function. The power 1 over 3. I can take the limit inside. Sorry. Since the cube root is a continuous function. That gives me what? Same degree. So that's 1 over 8. Cube root of 1 over 8 will be what? Half. So y equal half is the horizontal asymptote. Okay, what he want? He want the sum of these two values. So what will be the sum? I have minus 1. Here I have half. So the answer is minus. This one, where is the control? The control with the highest power. The control with this one. So I have minus 6 times infinity. That will be minus infinity. So this is my answer. Here I can take the limit inside. I can distribute the limit for by. This is tan inverse. Okay. This is by. Who cares? I can take the the limit inside. So that will be tan inverse of this limit. Okay. Now, what is the limit of this? Where is the control? The control is here. So this will be the same as this limit, which is minus infinity. So this goes to minus infinity. Tan inverse of the minus infinity will be what? Minus pi over 2. So the answer is pi plus pi over 2 because of this minus times minus. And that gives me 3 pi over 2, which is this. Tan inverse of this, I can take the limit inside. You get what? Tan inverse, do it in a step, of the limit of this one. That will be what? Now, if you apply the limit, I know that this goes to what? It will be eus minus infinity, which is 0. So I have 1 over 0 minus 1. That gives me tan inverse of minus 1, which is what? Minus pi over 4. That will be the answer. Len. What I will do with len, I need something over something. So I say limit x goes to infinity. It will be len. This is, I know that len a minus len b, provided everything is defined, it will be len a over b. So that will be 2 plus x squared over 1 plus 2x squared. Since ln is a continuous function, I can take ln outside, or I can take the the limit inside. The same idea. Okay, that will be what? Ln. This is same degree, so that will be ln half. Ln half, which is what? Ln 2 to the power minus 1, which is minus ln 2, using some properties of ln. This one, I have ln, but I don't have ln in the other side. Okay, so this one is what? I can write it ln ax. Oh, you need also the vertical asymptote. How many vertical asymptotes? None. No vertical asymptote. Why no vertical asymptote? Because this is defined. I have this one is positive, e to the power x is positive. If you notice the e to the power x, the function is always positive and negative. Actually positive. Times 3, it will be positive, plus 1, so this is greater than 1. So it's always defined. So from where the vertical asymptote will come? I have no vertical asymptote. So when you think about the horizontal asymptote, I'll do this trick. I'll change this into ln ax. So f of x will be ln ax minus ln 3ax plus 1, which is ln ax over 3ax plus 1. Okay, now I need to find limit. X goes to, let me start with minus infinity of this function. We'll have a problem. Why? Because this will go to 0, and this will go to 0. So you have ln of 0, which is undefined. So we cannot have a horizontal asymptote from limit goes to infinity. X goes to minus infinity. Now what about limit x goes to infinity of the same function? I can do this trick. Let me, just to save space, let me do it here. Yeah, I have limit ln. I can take in the denominator e to the power x as a common factor. I have 3 plus e minus x. Because I can deal with e minus x easily as it goes to infinity, because it will be coming 0. And these things cancelled. So you have limit, it goes to infinity, ln 1 over 3 plus e minus x. I'm doing it in steps. Take the limit inside. What is this? Yeah, I can take the limit inside. Yeah, I can cancel this because this is cannot be 0. Yeah, no problem canceling this. So I can take the limit inside. That will be ln. Actually, I'll take the limit inside from the beginning, but it's okay. Like what we did here. Actually, I need to take the limit inside to do this. Huh? Yeah. So this is just write it correctly. The same answer, but kind of writing. So this is will be ln 0 over 0 plus 1, which is impossible. So this one, take the limit inside. Actually, you cannot take the limit inside if the things are not defined. Okay, so that will be 1 over 3 plus e minus x. That will be ln 1 over 3, because this goes to 0. So this is the answer. So I have y equal 1 over 3 is a horizontal asymptote. I have only one horizontal asymptote. So this is my answer. Yeah. I have more functions. Let me do this one and then I will stop. The product of all case for which y equal k is a horizontal asymptote. We have what? Absolute value. So we need to do it with the absolute value. Get rid of it as it goes to infinity. This would be equal to x. So I have x over x plus 1, same 3, that will be 1. Limit x goes to minus infinity. I need to get rid of this. This will be minus x, since this is a negative. Minus x over x plus 1, that will be minus 1. So you want the product of all of these cases. So you have y equal minus 1 and y equal 1. These are horizontal asymptotes. product will be 1 times minus 1, which is minus 1, and that will be the answer. Yeah, let me stop here. I don't like to have long videos. Yeah. Let me stop the recording.